Okay, so here we have a chain, okay, that is initially on the floor here, and you want to raise it. This chain is 20 feet long or 20 foot long. I think it's more correct to say 20 feet long, okay, and you want to raise it. But the more you raise it, okay, you want to know the work that it takes to raise it, but the more you raise it, the heavier it gets, because right now it's on the floor and you want to raise it up to 20 feet, okay? So what's going to be the amount of work? Well, you see, the work that it takes to lift it, for example, a very small work is going to be equal to, or what you can do is like, oh, okay, whatever. Okay, no. I'm going to take a different approach. What's going to be the instantaneous force? The force is the density, the weight density of the chain is 5 pounds per foot. Okay, so if you lift it 10 feet, for example, what's going to be the force? Well, it's 5 times how much you lifted, which is just y. Okay, that's going to be the instantaneous force. For example, let's just say that you lifted 2 feet, so you got to pay, the force is 10 pounds. If you lifted 1 feet, it's going to be 5 pounds. All right, so what's going to be, this is the instantaneous force. When you integrate this force with respect to the dimension of displacement, which in this case is just y because it's vertical, going to be dy. Okay, this is going to be the derivative of the force with respect to y, or actually, and you could say that, well, when you put the dy, okay, this is the instantaneous force, okay, the derivative of the work with respect to y in this case is the instantaneous force. So when you put the dy in here, what you have is the derivative of the work, okay? So when you integrate this, you get the work. So what's going to be the work? It's going to be the force, the integral, right, of the force, which is 5y dy. And it's going to go from 0 feet to 20 feet because that's how long the chain is. So this is going to be equal to, from 0 to 20, 5y squared divided by 2, okay? Putting a 20 here, it's 400 divided by 2, it's 200 times 5 is 1,000. 1,000 what? Well, it's going to be foot pound, right? Because, yeah, it's foot pound. Or you can say pound instead of pounds. 1,000 foot pound. Because the length of the chain is in feet and the force is in pounds. The weight density of the chain is 5 pounds per foot. Okay, that's it. That's a very simple one. So this is the amount of work that it takes to lift the chain. Now, I got another interesting one in here. All right, this is what you have. And I'm gonna read something here. I'm going to read the exercise to you. A quantity of gas with an initial volume of 1 cubic foot and a pressure of 500 pounds per square foot expands to a volume of 2 cubic feet. Find the work done by the gas. Assume that the pressure is inversely proportional to the volume. All right? So what's going to be the work? Again, work equals force times the displacement. Okay, now what's going to be the force? It says that the initial volume of 500, the initial volume of 1 cubic foot, and the pressure is 500 pounds per square foot. So you got a pressure equals force divided by area. This comes from physics. So the force equals the pressure times the area. Okay, what is the pressure? It's 500 per per cubic foot. Now, what is the area? Well, the area of this thing is just going to be pi r squared, okay? Because it's the area that the gas exerts pressure on. I know that this thing over here looks like it's straight, looks like something weird in there, but this is actually looking at the edge of a circle, okay? The piston over here, if you looked this way, you would see a disc, you would see a circle. The piston is circular. So the area of this circle in here is pi r squared. Now you don't have r, okay? But what do you have? You have pi r squared times the displacement. So when you multiply the displacement over here, you have the area and the depth. This equals the volume, okay? So this thing equals 500 pi times the volume, all right? Okay, and there's something else too. So the force, you see, this is going to be equal to the work, right? The work is the force times the displacement, which is the pressure. I'm going to put pressure like this times the volume. But how much of the volume? Well, since you are going just a little bit in the x, okay, you're just exercising a little bit of the x. So this thing here is actually going to be, because what I'm trying to say, guys, is that the pi r squared is not going to change. The radius of the piston doesn't change, but how much the piston goes or comes, that's what's changing. That's the dx. When you have pi r squared times the dx, you have dv, okay? The change in volume. Now, if the change in volume is infinitesimally small, then the change in work is also infinitesimally small, all right? Okay, now there's something else here. So if you do the integral of p dv, you're going to find the work, okay? You integrate this and you integrate this, you will find the work. I have to integrate this too. Now, what is p? Okay, it just said that p is inversely proportional to the volume. So you have p equals k divided by v. Okay, now you gotta find k, because you see what's gonna happen, guys, is that then this equals the integral of k over v dv. Now what is k? Well, it's saying that at a pressure of 500 pounds per cubic foot, okay, at 1 cubic foot. That's what it says. Look, a quantity of gas with an initial volume of 1 cubic foot and a pressure of 500 pounds per square foot. Yeah, so I have 500 pounds per square foot and the initial volume is 1 cubic foot. That means that K equals 500. So this thing here is going to be equal to the integral of 500 divided by V dV. And the volume, this gas over here is pushing the piston so that the gas, instead of being in a 1 cubic foot, is going to be in 2 cubic feet. So the work is to get the volume from 1 to 2. And there you go, it's set up. So now all you gotta do is like 500 times the integral of this, which is gonna be ln of v, right? From 1 to 2, which is 500 times ln of 2 minus ln of 1. And you go like, okay, so I have to find the ln of 2 and the ln of 1. There are two ways that you can think about this thing. ln of 2 minus the ln of 1 equals the ln of 2 divided by 1, which is just 2, okay? Another way of thinking about this is what is the ln of 1? Ln of 1 means that E is being elevated to something here that makes it 1. So what is this? This has to be 0. So this is just 0, okay? So it'll be 500 times the ln of 2, which equals, according to the book, approximately 346.6 foot-pounds. Okay, that's it.